Math lesson number 46. The isosceles triangle and triangle inequality. Congruence and inequalities exist among the sides and angles of a triangle. Classification of triangles according to sides. We have equilateral triangle, all sides are congruent. Isosceles triangle, two sides are congruent. Scalene triangle, no sides are congruent. So this is an example of equilateral triangle. This is isosceles and this one is scalene. Now let's have the parts of the isosceles triangle. In isosceles triangle DEF, the two congruent sides DE and FE are called the legs. DF is the base, so this is the base DF. Angle D and angle F are called the base angles, so these are the angles opposite the legs. And angle E is the vertex angle, so this is the vertex angle, angle E. Theorems related to isosceles triangle and triangle inequality. First theorem: if two sides of a triangle are congruent, then the angles opposite them are congruent. So in this example, so the two sides DE and FE are congruent, therefore angle D and angle F are also congruent. So let's have the proof of this theorem. Given DE is congruent to FE, prove that angle D is congruent to angle F. So first, we draw a EM. EM, which is the bisector of segment DF. So DM is congruent to MF. Definition of bisector of segment. So when we say bisector of segment, it divides or cuts the segment into two equal parts. So therefore DM is congruent to MF. Next, EM is congruent to EM. So this EM here is congruent to itself. That is reflexive property. Again, reflexive property. Next, we have DE is congruent to FE, that is given. DEM or triangle DEM is congruent to triangle FEM by SSS congruence postulate, because we have here the side EM is congruent to this, the side EM is congruent to itself, and the side DE is congruent to this. We have SSS. So the two triangles are congruent. Now, we need to prove angle D is congruent to angle F. So angle D is congruent to angle F because corresponding parts of congruent triangles are congruent as well. So therefore, if two sides of a triangle are congruent, then the angles opposite them are also congruent. That's the proof of the first theorem. Let's have the second theorem. If two angles of a triangle are congruent, then the sides opposite them are congruent. So this is the converse statement of the first theorem. So again, if angle D is congruent to angle F, then automatically DE, the opposite sides of those angles, and FE are congruent also. Let's prove theorem number 2. Given angle D is congruent to angle F, we need to prove that DE, side DE, is congruent to side FE. So first we draw EM as the altitude or height of this isosceles triangle. So EM. Again, EM as the altitude or the height. So angle, first statement, angle DME is equal to 90 degrees, which is equal to angle FME. That is definition of altitude or height. So when we say altitude, it is perpendicular to the base. So when we say perpendicular, it forms 90-degree angle. Okay, so this one here, angle DME, measures 90 degrees. So if this is 90, this is also 90. So they are congruent. So we have the first congruence, the angle. Next, EM is congruent to EM. So this EM is congruent to EM. That is reflexive property. So that's reflexive property. So we have the second congruence, side. Okay, the first is angle and then this is side. Next, angle D is congruent to angle F that is given. So we have now the side, the angle, and the angle. So finally, triangle DEM is congruent to triangle FEM by SAA congruence theorem. So therefore, DE is congruent to FE because corresponding parts of congruent triangles are congruent. So when the two triangles are congruent, their corresponding parts are also congruent. So DE is congruent to FE because DE corresponds to FE. So that is the proof of theorem number 2. Number 3, we call this theorem as the exterior angle theorem. So the measure of the exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. In this figure, the exterior angle is angle D, this angle here, and the two remote interior angles are angle A and angle C. So the angles that are not adjacent to angle D. So those are the two remote interior angles. So the sum of A and C, according to the theorem, is equal to angle D. So let's have the proof of that theorem. So angle D is the exterior angle that's given. Angle D and angle B form a linear pair. Okay, that's also given. Now let's prove that angle A plus angle C is equal to angle D. Let's prove the exterior angle theorem. First, angle D plus angle B is equal to 180. And that is because of the definition of linear pair. So linear pair are angles that are formed on a line. So for example, this one, angle D and angle D. So we have here a line. And these are the two angles. And the two angles are supplementary. The sum is 180. So that's why angle D plus angle B is equal to 180. Next, angle A plus angle C plus angle B is equal to 180 degrees. Why? Because the sum of the interior angles of a triangle is 180. So angle A, angle B, and angle C have a sum of 180. Next, since angle D plus angle B is equal to 180, we substitute this with this angle D plus angle B. Substitution. Next, we remove angle B and angle B. As a result, we have angle A plus angle C is equal to angle D. Simplification. That's the reason. And that is the proof of the exterior angle theorem. Let's have some properties regarding inequality. So transitive property of inequality for all real numbers A, B, and C. If A is greater than B is greater than C, then A is greater than C. So for any three real numbers. So for example, I chose the three real numbers 10, 5, and 3. So in this situation, we have 10 is greater than 5, and then 5 is greater than 3. Automatically, 10 is greater than 3. So that is transitive property of inequality. Let's have trichotomy property. Two numbers A and B can either be A is equal to B, A is greater than B, or A is less than B. So if I have two numbers, let's say in this example, the two numbers are 4 and 4, then 4 is equal to 4 falls on the first situation, A is equal to B. Let's say I have here another number 5 and 3. 5 is greater than 3 falls under the second situation, A is greater than B. Next, I have two numbers 2 and 6. 2 is less than 6 falls under the last situation, A is less than B. So that is trichotomy property of inequality. Two numbers A and B can either be A is equal to B, A is greater than B, or A is less than B. So either of the three. Next, let's have number 4, theorem. Fourth theorem. If one side of a triangle is longer than the other side, then the measure of the angle opposite the longer side is greater than the measure of the angle opposite the shorter side. So in this figure, AC is longer than BC because AC is 34 and BC is 32. Now the angle opposite of AC is angle B, and the angle opposite of BC is angle A. Since AC is greater than BC, then angle B is greater than angle A. So generally, AC, in this figure, AC is greater than BC, greater than AB. Therefore, angle B is greater than angle A, is greater than angle C. Let's have the fifth theorem. If the measure of one angle in a triangle is greater than the measure of another triangle angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So in this figure, angle B is greater than angle C. So angle B is greater than angle C, which is greater than angle A. Therefore, AC, that's opposite the angle B, AC is greater than AB. AB is opposite angle C, is greater than BC. So BC is opposite angle A. So that is theorem number 5. Let's have the sixth theorem, the triangle inequality theorem. So we name this as the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So I have here an example. 7 plus 12 must be greater than the third side 15, which is correct because 7 plus 12 is 19 and 19 is greater than 15. 12 plus 15 is greater than 7, correct. 7 plus 15 is greater than 12, which is also correct. Therefore, the three sides of this triangle are valid. So that is the triangle inequality theorem. Let's have the seventh theorem. If two sides of one triangle are congruent to two sides of another triangle, so DE is congruent to AB, DF is congruent to AC, and the included angle of the first triangle is larger than the included angle of the second triangle, so the included angle here is angle B, which is greater than angle A. This is 100 degrees, this is 65 degrees. Then the third side of the first triangle, the side opposite the included angle, EF, is greater than the third side of the second triangle. So since angle B is greater than angle A, then EF must be greater than BC. So in short, if DE is congruent to AB, DF is congruent to AC, and angle D is greater than angle A, then EF is greater than BC. That is theorem number 7. Let's have the last theorem. If two sides of one triangle are congruent to two sides of the second triangle, and the third side of the first triangle is longer than the third side of the second triangle, so in this figure, DE is congruent to BF, DE is congruent to AB, DF is congruent to AC, EF is greater than BC. Therefore, angle D, the angle opposite the third side, angle D must be congruent to angle A. So in short, if DE is congruent to AB, DF is congruent to AC, and EF is greater than BC, EF is greater than BC, then angle D is congruent to angle A. So that is the last theorem.